problems. But this is called the principle of exponential equality. And what it says is that if I have a to the x, it's equal to a to the y, then x equals y. And I look at this and what I say to myself, the bases are the same. Means exponents are equal. Now, by the way, I have been, as we've gone along, as I've finished a section and I've worked out everything in terms of the packet, pre-sending it over to the copy center to see if the packet's going to work. I've been scanning these pages in. So everything is scanned in. I'm now finished through 9.3. Your packet only goes through, essentially, is this packet covers 9.1, 9.2, 3, 4. You haven't gotten 9.3 yet, but 9.3 is finished, scanned in. 9.4 is now finished, not scanned in. I have to go through and I have to work through the packet yet. And so 9.4 will be up sometime today. So I'm actually, my handwritten notes are actually well ahead of what the videos are. So they're going to be up and available. So even if the videos aren't up yet, the handwritten notes will be up where the note packet is. Anyway, so what that means is this, and let's look at something simpler in what this particular problem is. And so suppose what I have is 3 to the x equaling 3 to the 2. And that's fairly simple. So if 3 to the x equals 3 to the 2, if the bases are the same, what that means that the exponents must be equal. And that has to make sense, because if I have a 3 to a power equaling a 3 to the power, the two powers should be the same in order to be equal. They can't be different in order to be equal, because they've got to create the same number on both sides. Now, this is where your powers table is once again your friend. Remember our old powers table, it's going to come back and you're going to be able to use it in this chapter again. This one says, if 2 to the 3x minus 5 equals 16, well, the bases are not the same. But the question I ask myself, 2 is a prime number, can 16 be written as 2 to some power? Our powers table would say that 16 is 2 to what power? 4. So then I can rewrite that equation as 2 to the 3x minus 5 equals 2 to the 4th. So if the bases are the same, then the exponents must be equal. So that 3x minus 5 equals 4, 3x equals 9, x equals 3, and then you can go in and check your answer if you would like. The domain on exponential equations is all real numbers, and we're going to talk about domains again. Remember, domain of the exponential function was all real numbers. So he doesn't have a problem, so you can check your answer if you would like. Pardon me? Because A is a base. So if I think about A as being a base, if A to the 5th power, well, if A was 1, what's 1 to the 5th? 1. What's 1 to the 20th? 1. What's 1 to the millionth? 1. What's 1 to the minus a million? 1. So it's kind of like, well, it's always 1, so it doesn't make sense to have it be 1. So that's why they throw 1 out. Yeah. Good question.